Hey everybody, it's Mrs. C, and I am hopefully coming to you with a real quick video, just an overview of inequalities, set, graph, and interval notation. So just going to jump right into it. A lot of you are just a little confused about how to express your solutions for inequalities. So here we go. If you get the answer, say x is less than or equal to 5. You've solved an algebraic inequality and this is your answer. This, guys, is called set notation. And so this would cover your solution written in set notation. Because we have more than one answer when we do inequalities, we actually have infinite answers in simple inequalities. We have to have a way to express those inequalities a little bit more intuitively than just say one answer. And this is why. What does x is less than or equal to 5 look like? What visually, like what is that? How do you understand it? Well, sometimes graphing it helps us understand what it looks like. So if we had 0, and we always do in the center of the number line, we would put 5 on the right side of 0 because that's the direction of all of the infinite positives, right? And over here on the left are our infinite negatives, just meaning that the line goes on infinitely in one direction or the other. So if I was to graph this, I would have to have, because this is a closed interval, meaning it has a line underneath it, it gets a solid circle. The solid circle is just telling me that I am including 5 in my solution set. Now I also have to shade all of the values that x could be in this answer. And if we look back over here at the x is less than or equal to 5, tell me a number that x could be which would actually be less than or equal to 5. Well, equal to 5 is easy. I already have a solid circle on the equal to part, but now I need to represent all of the numbers less than. And so those numbers would be in that direction. A number less, say we would say maybe a negative 10. Negative 10 is less than 5, and so I would shade in the direction of negative 10. Negative 10 is over here, but so are another infinite set of numbers. So that would be graph notation, or, a graph of the solution. There's one other notation that we've been using, or we will be using in algebra, and that is called interval notation. Now, what interval notation does is it takes the number line. I'm just going to draw the number line a little bit bigger down here. And it takes what we know about the number line, the fact that numbers come from negative infinity and they extend out into infinity. I like my 0 just to help me orient the sides, the negative sides and the positive sides. So when we express something in interval notation is actually a letter number notation that looks like the graph itself. So if I am coming from infinity, interval notation always being read from left to right, the way you read. So I'm always looking at my graph from the left to the right. I have to understand a couple things about interval notation. And again, this is just talking about the 3 ways to express. I'm not really teaching you interval notation. I have a couple videos on interval notation that you can view. Just be careful. Don't watch compound interval notation. That can be compoundedly more confusing. You want just simple interval notation. When we have to substitute, because it's a different notation, we need a symbol to take the place of the solid and the open circle, and we have that. Instead of a solid, if we're going to include a number or a value, we use a bracket. And if we are going to exclude or do the open circle, we use a parenthesis. And you do just have to memorize that. Open interval is a parenthesis, closed interval is a bracket. So if our graph actually has a solid on the 5, then instead of using a solid, I would use a bracket. Now, because I am shading in this direction, it appears, I use the bracket, and I actually make the bracket go this way. You'll see, it just makes more sense. It doesn't really matter, it just looks better. So the shade was going this way into negative infinity. We already have that. So we actually have everything we need to interpret this graph. But remember, interval notation is read from the left to the right, which means I have to start with negative infinity. I write negative infinity. I put a comma just to separate, and I write where I'm ending. So I'm coming from negative infinity, and I am stopping at 5. The bracket tells me I'm including 5 when I stop instead of a parenthesis. Then comes the question of, what do I put here? I have to start somewhere. Now, infinity goes on forever, so you can't close infinity. You can never use a bracket on infinity because you would be saying I'm including negative infinity in my answer, and you can never include infinity. It's like trying to hold water in your hands. It just keeps slipping away. So we always open infinity or close infinity with a parenthesis. And this is the interval notation for x is less than or equal to 5. It's a parenthesis, negative infinity, comma 5, bracket. And if you look, it actually looks shockingly an awful lot like what you have up here. I'm starting at negative infinity. I'm proceeding up to and including 5. These two are almost identical. This one is just more simplistic without all the extra stuff. Let's try something else. Let's try, I'm going to go back to my black. Here we go. Let's try x is greater than negative 2. Now, that is set notation. I already did a problem and I got my answer, and it's in set notation. There it is. X is greater than negative 2. I need to graph it. I want a graphical representation. Negative 2 is over here. This time I am shading all values that are bigger than negative 2. That shade would be this way. These are all the numbers going bigger. Name a number bigger than negative 2. How about 5? 5 is bigger than negative 2. And that's why I'm shading in all the values that could be the x value. Now my last thing is I want to put something here. A lot of my students leave it like that and they get points taken off. I need open or closed interval. In the case of this symbol, it doesn't have a line underneath it, so it's going to actually get the open circle. So we're open on the negative 2. I am excluding it. I'm not counting negative 2. Negative 2 is not a number that is bigger than negative 2, right? Think about it. Negative 2 is not bigger than itself. It is itself. So it only gets included if there's a line underneath it, meaning equal to. All right, last step, that's it. That's your graph, guys. And the last step is to just interpret this into interval. Remembering that I read from left to right. This time I'm actually starting with the negative 2. Was it an open or closed interval? It was an open. So it's a parenthesis, open interval on negative 2, proceeding all the way through positive infinity and never including infinity. It's an open interval. That's it. That's all you got to do. A lot of times some students will look at me and go, that looks like a coordinate. That looks like an ordered pair. I know it does, but it's not. Remember that. It's not a coordinate. Let me try one that looks like this. How about a negative 5 is less than x? Kind of switching the x to the other side. It doesn't matter. That is set notation. You don't have to reverse it and put the x on the other side. But can we graph it properly when it's written this way? I hope. If you're thinking, using those minds, those beautiful brains of yours, you should be able to do it perfectly. Negative 5 is to the left of 0. Now remember, you're shading all values that satisfy x. So give me a number that x would open to. You see that the inequality symbol is turning away from the negative 5, which means what? It's smaller. So it always opens to the bigger value. So give me a value bigger than negative 5. Come over here and put any number. 10, right? 10's bigger. If I were an alligator, I would eat a 10 more than I would eat a -5. And so there you have it. You know what direction to shade. Don't use any tricks about the direction it points. Just think and shade where it makes sense. It's so much better. All right, so now let me change my color for the shade. And let's just look at it. Is it an open or a closed interval? There's no line underneath it, so it's an open interval on -5, and I'm shading towards the number I said would satisfy this inequality, which would be a 10. So I'm shading towards the 10. Now, please understand, this 10 is not part of my solution graph. It's extra information. There are an infinite number of numbers I could have written, and I don't want to muddy the water. I just want a nice clean graph, just like this. Open interval on the -5, shading to the right. How do I write that in interval notation? Well, I start from left to right, which means I'm starting right here. Parenthesis, open interval on the -5, comma, proceeding through infinity, close parenthesis. Okay, let's try one more thing. I want to give you the graph. I'm going to give you the graph like so. I don't know, 0. La 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 la. I'm going to put a -3 here, and I'm going to do solid, and I'm shading this way. Can you tell me what the set notation would be for that one? Can you tell me that? Well, let's start. The easiest way, I think, to do it is to put the x in the front, x. And you know the -3, it goes there. So you're always going to have an x value, and you're going to have the number that you see there. We know that it's going to have a line underneath it because it's a closed interval. What we don't know is what direction it should be pointing. So all you have to ask yourself are the values that are shaded, which are the x's, are they less than -3? Or are they greater than -3? And something easy for you is to just pick a value that would fit there. This helps you. Well, -10 would fit in there, in the shaded region. -10 is included. So if x could definitely be -10, which direction would the sign open to if it always opens to the bigger number? And -3 is bigger than -10. Don't get confused. Remember, the bigger the negative, the harder they fall. The bigger the negative, the smaller they are. And so that would be my notation in set notation. X is less than or equal to -3. Now, if I'm going to also need to do interval notation, I'm just, again, getting rid of all the excess. That helps you do it, but you don't want to put it in your final answer. How would I write that in interval notation? Well, this time from left to right, I'm coming from -infinity. Open interval, always on infinity, proceeding to, what was this number? -3, stopping and including -3. And there are our 3 different representations of the exact same answer. You have your set, you have your graph, and you have your interval. And the rest, my dear friends, is just practice. Go practice. Practice getting one, writing it in the other way. Start with interval, try to graph and do set. Start with set, do graph and interval. Start with graph, do interval and set. Just mix it up so that you can easily interchange these versions. They are all the same thing. It's like saying 1/2 is the same as 0.5. They look different, but they're the exact same value. They're different versions of it. One's a decimal, one's a fraction, but they're still representing the same information, and that's no different than what we're doing here. Same information, just representing it differently. Oh my goodness. All right, not too bad. Under 15 minutes for me. That's awesome. Usually I take a little bit longer. So there you go. Hope this cleared up a little bit. If not, it just left more questions, and I just need to do another video. So that's all I got for you today. And you know what? You know what I'm going to say, right? See you on the flip side. Peace.